Okay, guys, I would like to continue our foray into trigonometry. In this video, I'm going to talk about how to find an angle in a triangle if you know two side lengths, but you don't know the angle inside there. So in this triangle, triangle DEF, I don't know what that angle is. And the question asks me to find the indicated angle. So it's basically going to be, this angle right here from this line to this line. What is that angle right there? And it's labeled by theta. That's the variable that we use to label it. And so we're going to use the trig ratios that we had talked about before, SOHCAHTOA. Sine is the opposite over the hypotenuse, cos is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. And so what we have to do is we have to go from the angle we're looking for. So we're looking for angle E right here. We're looking for this angle. And the sides that I have, well, I have this side right there, 25. It's 25 units long. What side is that compared to my angle theta? Well, it's definitely not the hypotenuse because the hypotenuse is always across from the right angle. That's the hypotenuse. So 48 is actually my hypotenuse. This side, it's not the opposite side because the opposite side is across the triangle. So the only one left is it's the adjacent side, adjacent. And so we look at SOHCAHTOA and we're dealing with the adjacent side and the hypotenuse, which means I'm going to use cosine. Because cos is the adjacent divided by the hypotenuse. So I'm going to set this up as this. The cos of theta, so your angle always goes beside sine, cos, or tan. So the cos of theta, and I don't know what it is yet, but I'm going to find it out. That equals the adjacent divided by the hypotenuse. So in other words, the cos of theta equals 25, because that's the side length, divided by 48. Now, we got to this point in an example yesterday, or the day before anyways, in your assignment where I asked for the ratio for this to find the ratio of the cos of theta. But I want to do a little bit more here. I actually want to go ahead and find the angle. So in order to find the angle, what I have to do is I have to get this theta alone on this side. So I have the cos of theta, but I have to actually get theta by itself. And in order to do that, what I have to do is, this is a little bit of algebra. I have to take the second function cos, which looks really weird. So it's like the cos to the power of -1. It's called the second function cos of this side. But if I do that to one side to, remain, what's the word I'm looking for? To be even, I suppose, I have to do the second function cos to the other side as well. So this side, I'm going to take the cos -1, the second function cos. What it means is theta will equal, so the angle measure will equal the second function cos of 25 over 48. Now, if I lost you with that explanation, all you really need to know is that if you're finding the angle here, on your calculator, you're going to take the second function cos of this fraction. You're not going to take the regular cos. So on your calculator, you have to push, and I call it the second function because there's a second function button, and then you hit cos, the cos button, and then you put in your fraction, 25 over 48. So when you do that, second function cos 25 divided by 48, and a lot of times you have to, like your calculator will come up with a bracket here. You're going to have to close the bracket too. And you press enter, you should get a value of theta equals 58.6 and change. That means that the angle there is 58.6 degrees. So I found what the angle is in my triangle. If we go back to the triangle up here, I'm in blue up there on the triangle. That angle right there is 58.6 degrees. Now, if you didn't get that answer, either you punch this sequence, the second function cos and the fraction, into your calculator wrong, or you're not in degree mode. Again, if you don't know how to get into degree mode, then message me on Google Hangouts and we will chat. Okay. So let's try the next example here too. If you want to, you could stop the video and try it yourself and then see how you do. Might not be a terrible idea, but I'm going to go through it right now. Here is my angle. My angle is this one in the corner in blue. It's theta. In my triangle ABC, it's angle B that I'm looking for. So I have to find the sides that I know. I know this side right here. Is that the opposite, the adjacent, or the hypotenuse? Well, it's the adjacent again. And then this side right here is the hypotenuse. Don't let the orientation of the triangle, by that I mean, the triangle looks like this. Oh, my pen is terrible. That was not good. I'm going to erase this. But the orientation of the triangle, don't let that freak you out. The hypotenuse is always directly across from the right angle. And then your other lines, like this would be the opposite to my angle, and this would be the adjacent. And so, again, I'm working with the adjacent and the hypotenuse, so I'm going to use cosine again. If it was the opposite in the hypotenuse, I would use sine, but just in exactly the same way. If it was the opposite over the adjacent, I would use tan, but in exactly the same way. So the cos of theta will equal, in this case, the adjacent is 11 and the hypotenuse is 20. So it's 11 over 20. Now I'm looking for the angle. So I'm going to find the angle, I'm going to take the second function cos of 11 over 20. So in your calculator, again, you go second function cosine, and then 11 divided by 20. Close the bracket, you should get 56.6 degrees. 56.6 degrees. Okay, I hope that makes sense. So in any question that says find the indicated angle, that's what you have to do. You use your ratios, SOHCAHTOA here, but instead of using just the regular cos or the regular sine, you use the second function cos or the second function sine. I hope that makes sense.